Hi, my name is Ankur Majumdar and behind the camera is Mitra and we are from Team JP Institute of Information Technology. Today we are going to present our solution Sanchar Mitra. We are going to participate in the Physical AI Challenge India 2026 which is hosted by Robo.in. According to the 2011 Census of India data report, around 5 million people in India reported speech and hearing impairment. For them, something as basic as communication is a daily life burden. Imagine yourself, you're not being able to express your feelings freely. That is the reality of millions. Now, from this Sanchar Mitra project, we are aiming to solve two major problems. The first problem, as I mentioned, the speech and hearing impaired people, in 2026, AI is a buzzword and every product have AI in it. But most of this AI depends on extensive GPU support and overhead cloud infrastructure. So, and the second thing is that even in this massive AI development, a large part of the society, especially speech and hearing disabled people, are being left around. So we asked two questions: Can AI be made truly accessible for all, and can AI be deployed on resource-constrained edge hardware? So we came up with Sanchar Mitra. Sanchar Mitra is a bi-directional humanoid communication assistant that bridges the gap between speech and hearing impaired people and others. It is made under the vision of AI for all and AI for everyone. Now I would like to show you the technologies that we have used to make the Sanchar Mitra. For this, the main microcontroller board development board that we are using is the Arduino UNO Q. As you know that the Arduino UNO Q hosts a Qualcomm DragonWing N2. Apart from that, it also has a STM32 microcontroller. So on the Qualcomm DragonWing, and this is the second is the breakout board. This breakout board comes from the ST Microelectronics. This have a MIPI CSI2 camera and a screen. So we are thinking of making a wearable, and as you know, there is a specific column where we can attach the Arduino UNO Q. As you can see that it can be easily snapped here. Now through UART, this can communicate with this board. And apart from that, we are using a microphone that is being connected with the Arduino UNO Q and a speaker. Now, and in the software side, we are using the Arduino UNO App Lab. In the app lab, as you can see that there is a Python folder and the sketch folder. The Python folder is running on the Qualcomm DragonWing, through which we have made this UI. And through the sketch.ino, we are going to, control this matrix. Now, let's jump to the demonstration process. So for this, as you can see, there are three modes in this. First mode is the communication mode. In the normal communication mode, as you can see, there are three options: talk, display, and clear. As I mentioned that there is a microphone. So in the first scenario, what we are assuming that a normal person wants to communicate with speech and hearing people. So what he will do, he will choose this talk option and hello, how are you? And you can see that it is being displayed on this matrix as well. Now we can display anything. Hi, how are you? And this is Sanchar Mitra participating in Physical AI Challenge. And we can also control the speed of this data rate. We can clear it also, and want to display something else, we can also do that. Ankur. And yeah, now for the second part, we have this reverse communication mode.
Basically, we have used a normal ML classifier of random forest, in which I've used Google's MediaPipe 21 landmark points you can see here, which are being mapped on my hands, and I've used custom data plus data available on the Kaggle. So as you can see, it's trained on ASL right now. So if I do just
so as you yeah.
You can see here also it's showing, and here you can see all the interferences and whatever the CPU load right now is.
So so in this we have on the STM32 board, we have the model is running on this, and from the STM32 board, it is sending it back to the Arduino UNO Q through UART communication. And on the Arduino UNO Q, what we have done, we have run a custom random forest classifier, which is classifying these 21 hand landmark data points. Now I would like to ask Matre to demonstrate ABCD and he is doing the gestures, and as you can see, it is being displayed on this matrix C and B, L, E, D. Now imagine Matre wants to communicate back to me and want to say that he is fine. So I am fine. So what he will do? He will do the gesture I. Sent
Fine.
So as you can see, both are being shown here. And so the third mode is, as we mentioned earlier, that it is made under the vision of AI for all and AI for everyone. As you know, most of this, that nowadays whisper flow models and all are booming right now, and they are telling that we can communicate faster with the AI models if we speak. So for the speech and deaf people, what we have done is that we can talk with AI using just a hand landmark and sign gestures. So for that, in this, as you can see, that we have made a model Sanchar Mitra.latest. In this, we have used the Llama 3.2 parameter model, and we have given a system prompt. Now, now Matre will ask a question to the LLM. There is a button of AI interaction which we can use. So
W. WHH. O. AAM. I.
Now the Llama will speak out the response.
You're looking for someone. How can I assist you today?
So this is the AI interaction mode, and this sentence is also displayed back. The Llama response is also being displayed back on this Arduino UNO Q. So in this way, the speech and hearing impaired people can also interact with AI. So this was the final demonstration of our product. Now what we want to convey, we want to convey that AI can be truly accessible for all, whether it be speech and hearing impaired people or others, and it can also be deployed on resource constrained hardware. All the KPIs and the system architecture, that how we implemented it, is available on the GitHub and as well as on the on the Arduino project community. From this repository, which was uploaded by Vijay Barkade on 15 June, and on top of it we have added our own features such as TTS and other AI features. And thank you. And we are thinking this as the final implementation of our project, where the person can wear it, the speech and hearing impaired person can wear it as a wearable on his chest. And this is our project, Sanchar Mitra. We hope for the best. Thank you.